Hello, Isaac here. This is a short video just to show the functionality of this script, which creates this graphical user interface to apply auto-threshold methods into QuPath. I didn't have the idea. Actually, everything started here in this post from Yaomun Lim, in which he created a script to apply the triangle method to some images. And then through the discussion, everything improved. And in the end, we have this amazing script over here, which allows us to apply the different methods, auto-threshold methods into QuPath. So all the credits for Yaomun Lim. I just created the graphical user interface around because I wanted to know how to do it. And I got inspiration from this video of Pete Bankett of Create Surrounding Connotations, in which he creates this small user interface, right? So basically I took this script and I adapted to create what we have over here, right? So let's have a quick overview. We have here all the methods listed, all the channels of the image, then we can adjust the image downsample, the classifier settings, the post-processing settings, the output if you want annotation, detection, measurement, or threshold value, and 2 running options. So I'm going to use this image first. So we are going with the cytokeratin channel. Just run a square, run for selected, and here we have the segmentation for the cytokeratin, right? What it's nice is that we can use the QuPath tools. For example, here we have the brush tool, and we can also split the objects if we want. And here we have all the splitted objects. And also we have this other running option in which we can select the classification of the parents, and the auto-threshold method is going to be applied to each of the regions individually, right? So here, if it's unclassified, it's going to be applied to each of the annotations without any classification. And we can set here delete parent, and we have the auto-threshold method for both annotations, right? Another use that we have over here is, for example, if it's the TAPI channel. I don't think that this is the best use for this, but it's doing a good job too. For example, let's change the minimum area and the minimum whole area, and let's say that we want detections, right? So here we have our detection, and it's doing a good job if the cells are individually, right? But if we take like a bigger area, we have the problems that we would have on image J, right? But I think that it's doing a good job. Next, for another feature that I think that it's interesting, let's look at this hematoxylin image. One of the problems is that you have to rerun the script every time at the moment. So for example, here, let's put the average channel. Here we have the tumor, here ignore, 5000, and 5000 over here. And this the feature that I wanted to show, which is the auto downsample. So when applying these auto-threshold methods, the region of interest is sent to image to compute this threshold, and then you apply the classifier, right? So the user can choose manually this downsample, but if not, you are going to take the downsample of your current viewer, right? I got this inspiration from the segment anything extension, and let's check how it works. And here is the classifier. I'm going to put it at low resolution. So here we have our segmentation, right? And I think that although they are auto-threshold methods, they can be like really useful from some images. For example, let's say that we want to segment the epithelium over here. Let's change this to hematoxylin, full resolution. Let's say this to 500, 500, and here is ignore, and here tumor, right? So we have a really nice segmentation of this epithelium over here, and I think that it's doing a good job. So run for the parents, and here we have the segmentation from all of them. For example, here, if we want, we can apply some preprocessing, for example, dilatation, and just run for this annotation, run for selected, and also split the objects if we want. And now we have each of them almost individually, right? And finally, I'm going to show you another example with this image from my old times as neuroscientist. And this is database staining, but in neuroscience, sometimes the computer staining with metaxonomy is not done. So like in this image over here. And here, for example, we have the average channel, here tumor, here ignore. Well, let's change to just immune cells. And for example, those are classified as tumor annotations. So we can set here tumor, run for the parents, and it's going to be applied just to those squares. And if we change this to stroma, let's change to necrosis, for example, run for the parents is just applied to those squares, which are stroma annotation, right? So this is the quick overview of this graphical user interface. I think that it's a really nice feature that perhaps could be in QuPath into the future with the auto sample, for example. And I've done this as an alternative for the cement anything extension. At least I'm using it in this way in the lab. And this is because, for example, in this computer that I am right now, we have a super powerful CPU, but we don't have a proper GPU, right? And although with the cement anything station, it's everything really nice. If I put like a lot of annotation objects, sometimes it's quite slow and it gets stuck, right? So please use the cement anything extension, because it's amazing. I said here that I use it a lot, right? But I think that this could be like a nice alternative for applying this auto threshold method, right? So I hope that you enjoyed the video. Again, all the credits for Yao Lim for creating the core of this script. I just create this user interface. I'm going to share the code in GitHub, also in the forum. So thank you for your attention and see you. Bye.